Hello and welcome to another MUNSCI video. Today we'll be exploring part 2 of Suvat motion, which is called projectile motion. An object is said to undergo projectile motion when it follows a curved path due to the influence of gravity. This curved path is called the trajectory. Assuming air resistance to be negligible, we can conclude the following properties. Firstly, the horizontal component of velocity is always constant. In other words, there is no horizontal acceleration on the object during projectile motion. Secondly, the vertical acceleration during the projectile motion is always g, which equals to 9.81 meters per second squared. Thirdly, the projectile reaches its vertex or maximum when its vertical velocity is at 0 meters per second. And lastly, the trajectory of a projectile, which is this path that the object travels, is symmetrical. Now let's draw the vertical and horizontal velocities that an object experiences during a projectile motion. It can be seen that at the very instant of release, the vertical velocity is upwards and at its maximum. As the object approaches the vertex, vertical velocity approaches 0. Once the object has gone past the vertex, the vertical velocity increases again, but in the negative or downward direction. The horizontal velocity of the object is always the same as there is no horizontal acceleration. Based on this information, we can separate the projectile motion into horizontal and vertical components, which can then be solved separately using the Suvat equations. However, note that the object undergoes a projectile motion at an angle theta with an initial velocity u. For using Suvat to calculate the projectile motion, we must split the initial velocity u into a horizontal velocity and a vertical velocity. But how? Well, the method is simple. We can think of it in this way. At the instant when the object starts its projectile motion, we can basically view it as a right-angled triangle, with the angle being theta and the hypotenuse being the initial velocity u. By using basic trigonometry, which is SOHCAHTOA, we can relabel this triangle like this. The base is u cos theta and the height is u sin theta. And these represent the vertical and horizontal initial velocity. Now we have successfully splitted the initial velocity into separate horizontal and vertical ones. For the horizontal components, the distance s will be the range of the projectile. The initial velocity u will just be the base of the triangle, which is u cos theta. The final velocity v is also u cos theta because, as discussed earlier, there is no horizontal acceleration. Hence, horizontal velocity is always kept the same throughout the entire motion. Like I said, the acceleration a is 0. And lastly, the time is just t total, or t1 plus t2 when done according to the symmetricality of the trajectory. For the vertical components, s, which is the distance, will be the maximum height of the projectile, represented as h, which is the height of the projectile from the middle of the range to the vertex. The initial velocity u will be u sin theta, which is the vertical axis of the triangle. The final velocity v is 0 because v is always at 0 when the position of the object is at the vertex. The a will be acceleration due to gravity, g, which rounds to 9.81. time t is just t1 or t2 depending on the question, as the vertical component only calculates up to the vertex of the projectile motion. Now that we understand the basic principles of projectile motion, we can get into a few example questions. An arrow is fired horizontally from the top of a tower 35 meters above the ground. The initial horizontal speed is 30 meters per second. Assume that air resistance is negligible. Let's first construct the graph. As the arrow is fired horizontally from the tower, it should start at the vertex, with the h being 35 meters and the horizontal initial velocity u being 30 meters per second. Part A wants us to find the time, which means that vertical Suvat must be used. We know that S, which is the height of the tower, is 35 meters. U is 0 as the vertical initial velocity remains at 0 at vertex. A is 9.81. What is T? Which Suvat equation should we use? As we know U as A and we want to find T, we should use S equals UT plus 1/2 AT squared. Now we just bring in the values and calculate. As U equals 0, we can simplify to S equals 1/2 AT squared. Plug in the values and we get that T roughly equals to 2.7 seconds. In part B, we are asked to find the horizontal distance, S. Let's first draw that on the graph. It is just the distance from the foot of the tower till the point at which the object impacts the ground. In this case, we should use horizontal Suvat. It is given that u horizontal is 30. And because acceleration in horizontal Suvat is always 0, the final velocity v for horizontal Suvat should also be 30 in this case. And as we know that t is 2.7 seconds, we should also use this value here. Which Suvat equation should we use again? We should use S equals UT plus 1/2 AT squared again. Now bring the values. S equals 30t plus 1/2 AT squared. As A equals to 0, S is just 30 times 2.7, which gives us roughly 81 meters. The last part is C, where we must find the final velocity of the arrow. In this case, we use vertical Suvat. Again, acceleration is 9.81, initial velocity is 0, and time is 2.7 seconds. What Suvat equation should we use? The equation used is V equals U plus AT, as we know U, AT, and we need to find V. Now bring in the values. V equals 0 plus 9.81 times 2.7, which roughly gives us 26.5 meter per second. However, it is important to know that when asked to find the final velocity of the projectile motion, it must come with an angle to the ground, as velocity is a vector quantity. How do we find the angle of impact then? It is easy. We just make another right triangle with the base being horizontal final velocity, which is 30 meters per second as given in the question, and the vertical axis being the vertical velocity, which is 26.5 meters per second, and the hypotenuse being final velocity. And now we just use SOHCAHTOA to find theta. Tan theta equals opposite over adjacent, which is 26.5 over 30, and we get theta roughly rounds to 41 degrees. We have now mastered projectile motion and Suvat motion. I hope everything made sense to you so far and you enjoyed watching this video. Please subscribe to MÜNSCI for further interesting physics videos and STEM videos. See you next time. Good luck with your study.